Welcome to another transformative journey through the annals of scientific history. In this video, Top 10 Scientific Discoveries That Changed Our Understanding of Climate, we will delve into monumental breakthroughs that not only enhanced our knowledge of the Earth's climate system, but also drastically reshaped our perception of it. So strap on your thinking helmets, as we venture back to the roots of climate science and traverse through centuries of groundbreaking discoveries and innovations. Tune in and prepare to have your mind enlightened. Let's dive in. 1. Greenhouse effect, 1824. Back in 1824, a French physicist named Joseph Fourier made a breakthrough that would fundamentally change our understanding of how Earth's atmosphere works. He discovered the greenhouse effect, which is the process by which certain gases in our atmosphere trap heat, warming the planet. Fourier realized that without this effect, Earth would be much colder and inhospitable. His ideas were later refined by scientists such as John Tyndall, who identified specific greenhouse gases, and Svante Arrhenius, who calculated their warming potential. This discovery laid the groundwork for climate science, helping explain why Earth has a livable climate and how changes to the atmosphere can affect global temperatures. 2. Ice ages and Milankovitch cycles, 19th–20th century. The concept of ice ages was not always accepted. In the 19th century, Louis Agassiz championed the idea that much of the Earth had once been covered in ice. Building on this, Milutin Milankovitch later outlined the Milankovitch cycles, which describe how changes in Earth's orbit, tilt, and axial wobble lead to climate shifts, including ice ages. These discoveries helped scientists to understand the natural long-term climate patterns and the periodic frozen states the Earth experiences. Understanding these cycles is crucial for comprehending the dynamic and ever-changing nature of Earth's climate system. 3. Carbon dioxide as a climate driver, 1896. Svante Arrhenius, a Swedish scientist, made a prediction back in 1896 that is even more relevant today. He calculated that increasing levels of carbon dioxide in the atmosphere could raise Earth's temperature, essentially linking human activities such as burning fossil fuels to climate change. This was the first time anybody made a connection between carbon dioxide and global warming, spotlighting the critical role human-induced emissions could play in climate transformation. Arrhenius's pioneering work offered the earliest scientific evidence that our actions could significantly alter the planet's climate. 4. Ocean currents and climate, 20th century. The oceans are massive conveyors of heat, their currents playing a pivotal role in shaping regional climates. During the 20th century, scientists uncovered the thermohaline circulation, often dubbed the global conveyor belt. This process highlighted how ocean currents move warm water from the equator toward the poles and cold water back to the equator. It's a bit like Earth's central heating system, distributing energy around the planet. Discovering this helped us understand why certain regions are warmer or colder than expected given their latitude, and how shifts in these currents could trigger significant climate changes. 5. Ice core records, 1950s. The 1950s marked the dawn of a new technique in climate research, with scientists beginning to analyze ice cores drilled from polar ice caps and glaciers. These cores are like time capsules, containing air bubbles that trap gases from thousands of years ago. By examining them, researchers can reconstruct past climates and observe the historical relationship between carbon dioxide levels and global temperature swings. This discovery provided solid evidence of the linkage between atmospheric CO2 and climate changes, confirming long-term trends that span millennia and giving a clearer picture of Earth's climatic history. 6. Keeling curve, 1958. In 1958, Charles David Keeling started a groundbreaking project at the Mauna Loa Observatory in Hawaii. He began measuring atmospheric carbon dioxide levels, meticulously tracking them over time to produce what's now known as the Keeling curve. This collected data showed a clear and alarming increase in CO2 since the late 1950s, underscoring the significant role of human activities in altering the climate. The Keeling curve is a stark illustration of the upward trend in carbon dioxide, turning abstract meteorological data into undeniable evidence of anthropogenic climate change. 7. Role of aerosols, 1970s. Not all particles in the atmosphere warm the Earth. Some, like aerosols, have quite the opposite effect. During the 1970s, research on aerosols revealed that these tiny atmospheric particles could reflect sunlight, contributing to cooling. This discovery showed that aerosols, despite their cooling benefits, could disrupt precipitation patterns and have other unintended consequences on the climate. It demonstrated the complexity of Earth's climate system, where seemingly minor components could drastically influence climate by balancing or counteracting warming effects. 8. Satellite observations, 1960s present. The launch of meteorological satellites during the 1960s revolutionized climate science. These satellites provide a bird's-eye view of our planet, offering critical data on temperature, sea ice extent, and atmospheric composition. With these eyes in the sky, scientists can track changes in Earth's climate system more accurately and faster than ever before. Satellites have become indispensable tools in climate research, allowing us to monitor trends and transformations that occur on both local and global scales. 9. El Niño Southern Oscillation, ENSO, Understanding, 1980s. The 1980s brought significant advancements in understanding the El Niño Southern Oscillation, ENSO, a climate pattern that occurs across the Pacific Ocean. During El Niño phases, the Pacific warms and affects global weather patterns, while La Niña brings cooling. Scientists recognized how these cycles impact everything from monsoons in India to droughts in Africa, illustrating how interconnected our global climate truly is. Discovering ENSO deepened our understanding of how oceanic and atmospheric systems interact to drive climate variability worldwide. 10. Anthropocene in climate models, 2000s. In recent decades, we've entered what many scientists call the Anthropocene, where human activity is the dominant force influencing climate. Advanced climate models that incorporate human factors such as fossil fuel emissions have been developed to predict future scenarios. These models allow researchers to simulate potential outcomes based on different emission pathways, offering invaluable insights for policymakers. Understanding that we're now key players in Earth's climate system highlights the responsibility we carry and the potential for guiding climate action strategies to minimize impacts for future generations.